This one is the shortest module which you have, and questions can be asked among 3 topics. Okay, this is the shortest module and it's very simple. See here, first the questions can be asked from this one. So let's see what question can come. All the questions are of the same type. You have to follow the same steps. See, the question will be like this: find a Fourier series of this some function they will give in this one. The interval is this. Okay, so what's the step 1 you need to do? Step 1, you need to note down the interval. Okay, like 0 to 2 pi here, whatever be the interval here, it will be 0 to 2 pi or minus pi to pi. Okay, that's the only 2 options. So interval, after you have noted down, then you have to write a simple formula for all the questions. The formula is this same one. Okay, so you have to write this formula, and after writing this formula, see, you can remember like this: a naught an bn. Okay, and this one, this sigma n is equal to 1 to infinity will be here common, and with an cos nx and bn sin nx every time. Okay, an has cos, bn has sin. Okay, or if you confuse, a comes first, no, so c also comes first in comparison with b and s, right? So you can remember it in that way. After writing the step 2, what you have to do, this step 3, for each you have to calculate a naught, an and bn, then using a simple formula integration, then you have to substitute in that. That's all you need to do. So a naught formula is this. Okay, 1 by pi, what will be the interval, you write that one, 0 to 2 pi f of x dx. It will be the same formula for all. Okay, then after that, what is f of x they have given in the question? This one. Okay, that you have to substitute here. After you substitute, you can find the integration, you will get one answer here. Okay, substituting the limits. Now similarly find an also. An has the same thing, f of x cos nx, substitute e power minus x in f of x, then find this one. Now the third thing, bn also in the same way, just sin nx will be there. Okay, then after you find the 3 things, substitute in that formula. Which formula? This one. Yeah, you got a naught, an, bn. Just substitute all that in that formula and you will have the answer finally. Okay, this is the way you do this first part, full range series. Okay, and sometimes they can ask to deduce some equation also. That is very simple. What you need to do, if they ask you to deduce any series, what you have to do, you have to observe what value of x you put, that will give you the required series. Suppose I put here 0, what will be f of x, means e power 0, it will be 1, so here it will be 1, and here cos nx, it will become cos 0, that is 1, sin nx will go off, so only an will be remaining, and that way you need to calculate. Still, if you didn't understand, you can anytime contact me, I will explain you how to do that as well. Okay, this one is your second topic, which is half range Fourier series. It's very simple. Interval will always be 0 to some pi or 1. Okay, pi, 1, 2, anything. Okay, so interval will always start from 0. Okay, first thing, the same thing, if they give cosine, what you have to do, let me explain you. Write the interval here, 0 comma 1. First step, L is equal to 1. Second step, write the formula. For cosine you will have a terms. Okay, a and bn will be not there. Okay, so you have to write these terms and everything is same. This formula just has L here. Okay, if it is 0 to 1, L is 1, no, so you have to substitute here 1. Okay, now what's the step 3? You have to find a naught, an, then substitute in that final equation. So a naught formula is this one. It will be same for all the questions. 2 by L, 0 to L. For half range it will always start from 0. Okay, 0 to L, f of x. What is f of x? They have given in the question, x minus 1 whole square. Substitute that x minus 1 whole square and find a naught. When you get a naught, similarly find an also. We need not find bn. Okay, and after finding those, substitute both here, a naught by 2 plus in this equation, and you will have that final answer. In case of sine series, see, like they asked right here, they may give half range or they may not say half range, but if they say cosine Fourier series, you have to find the cosine and sine half range only. Okay, if they give sine, what you need to do, you need not find a naught and an, just calculate bn. For bn also that same formula only will be there, just here sine will be there. Okay, that's the only difference, and here bn will be there. All right, harmonic analysis is the last question, I mean the last topic in this module, and it is just 3 steps process. You need to just remember the process. Okay, the question will be in this form: compute the constant term. Observe here, constant term and first 2 harmonics. Okay, first 2 harmonics of the Fourier series. They will give one table here. Okay, now what you need to do, you need to see if any value gets repeated here in the first and last stage. If it gets repeated, you have to not consider this value. Okay, so what will be the interval? 0 to 2 pi. Even you are not considering that what value is getting repeated, that value, that interval you will take 0 to 2 pi. Okay, after taking that, that's the step 1. What you need to do next, make this table. See, this table is easy. Write xy, y cos x, y cos 2x, y sin x, y sin 2x. All right, xy, y cos x, y cos 2x, y sin x, y sin 2x. All right, now what you need to do, x, what is x? These all values, write down here. Okay, then what is y? For each x you will have f of x. No, this is y. Write all these values respectively. For 0, this pi by 3 till here. Okay, write all that. Then y cos x. What is y cos x? Y is this 1, cos x, cos 0. Cos 0 is 1. Cos pi by 3, 1.4 into cos pi by 3, 0.7. Like that only. Cos 2x means what? 1 into cos 2x. What is x? 0. 2 into 0, 0. Cos 0 is 1. Like that for this one, 1.4 into cos 2x. 2x means 2 pi by 3. Cos 2 pi by 3 into 1.4 is minus 0.7. Like that only you need to calculate for all. And similarly for sin x also, both the tables you calculate. Then you have to find the total for y, y cos x, y cos 2x, y sin x, y sin 2x. Okay, no need to calculate for x total. Except x, you have to calculate for all. Okay, when you find the total means just add these values in the columns which you got. Okay, so you'll have 5 values here. Okay, 5 values. Then what's the step 3? N is equal to 6. What is n? You just calculate after omitting how many values are left. 1, 2, 3, 4, 5, 6. All right, 6 values are left, right? So you have to calculate n value. N will be 6. Then a naught, that's the formula, 2 by n delta sigma y. What is sigma y? The sum you calculated, right? This is sigma y. Then you will substitute sigma y here, that is 8.7, right? So I substituted 8.7 here and you will get the answer as 2.9. Similarly, you have to find for a1. What is the formula for a1? 2 by n sigma y cos x. What is sigma y cos x? This one. Okay, you calculated in the whole column, right? Y cos x, that's why we are calculating total. Okay, then substitute this minus 1.1 in the place of this and you will have this answer. Okay, so you will get a1. Similarly, calculate b1, a2 and b2. Okay, these 4 things if you calculate, your work is done. The last thing which you need to write is constant term. See in the question what they had asked. See if you can, yeah, constant term. What is constant term? In constant term you will have no cos or no sine. Okay, that means a naught by 2. That will be the constant term always. Substitute value of a naught by 2. Write this answer. Then they have also asked you to calculate first 2 harmonics, means first harmonics and second harmonics. What does that mean? See, in the first harmonics you will have this formula a1 cos x plus b1 sin x. If they ask second harmonics, a2 cos 2x, b2 sin 2x. Okay, now what you need to do, a1 you got right, substitute a1 here and write cos x as it is. Like that 0.1732 for b1 and sin x write as it is. Similarly for second harmonics also you need to do this. Okay, questions will come with slight variation but the procedure is same, and for 90% of the questions if you follow this procedure, hopefully you can expect good marks. Okay, this module 3 is a very small module. Listen to what I say and you will understand each thing. And let me tell you that in exam whatever I will be discussing now, within that only in exam they will ask, and excluding that they can't ask from in exam because the it's out of the scope. Okay, so mainly see, module 3 is divided into 2 parts: Fourier transform and Z transform. Okay, in Fourier transform you have 3 parts here. So I'll be discussing the first one, infinite Fourier transform. Okay, it's all easy, just 1 to 2 minutes if you give me, you'll understand each topic. Okay, now see, first one here is Fourier transform. Okay, now see in exam what they will give, under the topic infinite Fourier transform you have f of s, this formula is there. Okay, just remember this formula. First one is infinite Fourier transform. Okay, then in that formula you have f of x is equal to, like this they will give, find Fourier transform of function f of x is equal to these things they will give, and then next question they might give, hence evaluate this one. Okay, so question is divided into 2 parts first. Okay, you need to observe here, question is divided into 2 parts. Solving the first part, see, step 1 what you need to do, you need to draw this line. Okay, draw this line from here till here, then mark as minus infinity to infinity, minus a to a, then here 0. Okay, then what you need to do, observe here, I'll show you one trick here. See, x is there. Okay, x is less than or equal to a. Okay, less than means less, so it should occur only lesser number of times, means one number of time and what will be the value here, that you have to write here. And this one is greater than. Greater than means whatever value will be here, that will occur more number of times at the boundaries, like at the end you will have zeros and zeros here. Okay, so this one is representing this thing, and this one is representing this thing, and this one is representing this thing. Means minus a to a, the value is 1, and minus infinity to minus a, and a to infinity, the value is 0. Okay, less thing will occur at the middle one time, and the greater means more, so it will occur more times at the boundaries. Okay, this is your step 1. After doing this, you have to go to the step 2, write the formula. Okay, directly f of s is equal to minus infinity to infinity f of x e power isx dx. Okay, for finding that, you will have to write dx. Okay, if you are finding Fourier transform, then this minus infinity to infinity is divided into 3 parts. This one is first part, second part, third part. Minus infinity to minus a to a, then a to infinity, 3 parts. Okay, so here its value is 0, here also value is 0. The only value which is available is here, right, minus a to a, so that you will consider here. Okay, that you will consider here, because only this value is available. Minus a to a, f of x e power isx, that's the same formula. Substitute f of x. What is f of x in this? Here it is 1, right? So substitute here 1, and then evaluate the integral, and you will have this answer. Okay, so your first part of the question is over. Okay, first part of the question is over. Now moving on to the second part, what you have, 0 to infinity sine x by x. Okay, now what you need to do, whenever you see evaluate, you have to find inverse. Remember this all the times. Whenever evaluate comes, you have to find the inverse. So for inverse also you have 2-3 steps. Very simple. See, first what you need to do, you need to see here, evaluate. For evaluate, you will write this. Okay, step 1. What is the step 1? For inverse formula, you will write 1 by 2 pi minus infinity to infinity f of s e power minus isx ds. When finding inverse, you have to write ds. For Fourier, you have to write dx for normal one. Okay, then what is the step 2? You have got the previous, in the previous answer, f of s, no, 2 by s sin as, that you will write here first. Then this f of s you will substitute here in this formula. Okay, when you will substitute, what you will get, 1 by 2 pi, this one thing, this you will substitute here into e power minus isx ds, this same thing here. Okay, then that's the step 3. Step 4, what you will do, you will take this 2 outside, you will cut this 2. Okay, then as you can see, sine as and s both are odd functions. Odd by odd function is even. So in even, what you will do, you will change the limit as 0 to infinity and multiply by 2 here. So it will be 2 by pi sine as by s e power isx ds. So ultimately what we need here, see, compare these both, sine x by x dx. Okay, here this extra term is there, e power isx. We can take any value of x and a. Okay, see here, sine x is only there, a is not there here, but we have here a. Okay, so what we can take, a as 1. If we take a as 1, what we will have, sine s by s ds, and e power isx will be 0, because e power isx will be 1 totally, because if you take x as 0, here it will be substituted, and e power 0 is 1, so here it will be 1, and here you have this one. Now what you need to do, see, when you take x as 0, okay, when you take x as 0, what will be the value of f of x? See, when you take x as 0 here, it will be here, right? When you take x as 0, see, or you can see here also, when x is 0, value is 1, f of x is 1, so you will put here 1 is equal to 1. Okay, then what we need, just this term, right, to evaluate this. See, 0 to infinity sine x by x dx, so only we need this term, so we'll shift this term here to get 0 to infinity sine s by s ds is equal to pi by 2. All right, that's the final answer for this second question. Okay, that's the way you solve this infinite Fourier transform question. For all the questions, it's the same thing. You'll have just this formula will differ, and some things will differ, but the steps are same. Keep in mind the steps and the tricks I told you, and it will be very helpful for you. Okay. Yeah, this one is the last concept, which is of 2 minutes. It's about Fourier sine and cosine transform and finding the inverse. Just a simple thing, they will give you this question, find the Fourier sine transform of this one. Okay, you have to note it down. What it is given, 0 less than x less than 2. Okay, so you have to draw for sine and cosine transform. The line will be from 0 to infinity, and whatever value they give here, mark it as here and write here x. For under this value it is x and 0 otherwise. Okay, so we need not consider this value in the integral. Step 2, write the formula. Okay, after writing the formula you'll have this 0 to infinity divided into two parts, 0 to 2 and 2 to infinity. For 0 to 2 only you need to consider 0 to infinity. 2 to infinity it is 0, so you need not consider this one. For 2 to infinity, what is f of x? It is x, so you'll write here x sine x. Okay, instead of f of x you will write x sine x dx. When you evaluate this one you'll have this thing. Okay, that's the Fourier sine transform. Now coming to the cosine transform, also is same one, just instead of here sine you'll have cosine sx, and the same way you will do this integration and all. Okay, and coming to the inverse, they'll give you the question like this: find the inverse of inverse sine transform of this, hence show that this. Okay, and you'll give f of x is equal to this. Now step 1, what you need to do, write the inverse formula for each question. First step is to write the formula. Okay, write the formula. This one is 2 by pi 0 to infinity f of s sine s6 ds, and then you will have 2 by pi 0 to infinity s, this one. What is f of s? This is what inverse we have to find, that thing you have to write here. Okay, fs of s is equal to s by 1 plus s square sine s6 ds. Okay, then step 2, what is f inverse of f of s? That is f of x. Okay, f inverse of f of s is f of x. F of x they have given here e power minus mod x. Okay, that you have to write here. Now comparing these two, this is f inverse and f inverse is f of x, which is this, so we can write this is equal to this, right? So we'll write here 2 by pi and this thing is here, we'll write is equal to this. Now what we need to evaluate here, see, 0 to infinity x sine mx by 1 plus x square dx. Okay, mx, here we have sx. Okay, everything is in terms of s, so instead of x what we will take here, we'll take as m. Okay, so here it will be s by 1 plus s square sine ms and e power minus mod x. Instead of x we took m, so it will be m, and this 2 by pi will transfer here, it will be pi by 2. Okay, now see, in this term it is s by 1 plus s square and sine ms. In here it is x sine mx by 1 plus x square dx. It is of the here it is of the form ds, so if you put here x you will get here dx also, same as this one. Okay, at last you make the substitution. This is the first topic under z transform, and this is my favorite one, and because it's a small one and easy to grasp type. Okay, so initial and final value theorem. Firstly you will have these formulas, you have to memorize these ones. Okay, then after that they'll give you the question like this: find u of z. Then this equation they'll give you. What you need to do, step 1, find u naught. Write the formula for u naught. What is the formula for u naught? This one is z tends to infinity u of z. U of z is which they have given. Write that limit tends to limit z tends to infinity. This one you will write here. Then what you need to do, in everything you will take the highest power of z from the numerator. When you will take that and you will cancel with this, what will be remaining here, it will be 1 by z square, and when 1 by z square will tend to infinity, it will be 0, so u naught will be 0 here. Similarly for u1 you will write the formula here and substitute uz, which is this thing in the question what they give, that you will substitute here, and minus u naught. U naught you have got here 0, so you will substitute here 0, and again you will do the same thing, take a z square common here and z power 4 common here, and you will get the u1, and similarly you have to find u2 and u3, and that finishes this initial value theorem. It was quite simple, right? Finding inverse z transform is a simple 4-step process. Firstly they will give you this question, z cube minus 20z, and we have to find this z transform. So step 1, we have to write u of z is equal to z cube minus 20z by z minus 2 cube into z minus 4. In second step what we will do, we will divide this u of z by z. Okay, so we will have here z square minus 20 divided by this thing. Okay, so after doing this, step 3, what we will do, we will write it as partial fractions. U of z by z is this, and we'll write it as partial fractions. And if you didn't understand why we wrote like this b into 2, contact me, I will explain you why we did that. And we have to find ABCD, and even if you face difficulty in this, how to find this ABCD, contact me, I will tell you how to find that ABCD also. Okay, so after finding ABCD, what you have to do, step 4, u of z by z, and we'll have your A, B, C, D, and we'll find the value. We have found the values of a, b, c, d. We'll substitute it in these places, and after substituting we'll see this one, u of z by z was here. We'll multiply this in the numerator here, so we'll have these things separately, and we'll find the z transform of each of these by using the formulas. By using the formulas we'll get this respectively, and this is the final answer for the z inverse. Z transform's last topic is difference equation, and in this they will give the question like this: un plus 2 plus 4 un plus 1 plus 3 un is equal to 3n, and they will give values for u0 and u1. Okay, step 1, what you need to do, take z transform on both the sides. Write like this: z of this is equal to z of this. Then in step 2, what you need to do, you need to take it separately: z of this plus z of this plus z of this. Okay, here also this. Now using the formula, you have this formula, right, for un plus 1. Wait, I'll show you where it is. Yeah, this one. See, here you have formulas for u1, u2, u3 and all. No, that only same formulas you have to use here also. When you will use that formulas and write for each things, un plus 2 this one, un plus 1 this one, and un this one, and for z transform of 3 raised to n is z by z minus 3. After writing this, step 4, you have to take u of z common from this. Okay, when you take common, you will have here z square plus 4z plus 3 minus z is equal to this thing. Then what you need to do, you need to keep u of z here and take everything here to the other side. U of z by z, it will be z minus 2, z plus 3, z plus 1 and z minus 3. Now you can refer to the previous video to find the z inverse after this point, and by using the partial fraction, and that will be your final answer.